Alright, hello again everyone. In this video I'd like to go over question number 19 from the homework. It is one of the rotational equilibrium questions. We haven't really covered much about this yet, so I thought we would do it by looking at one of the homework questions. So the question states, a 700 Newton window washer is standing on a scaffold supported by ropes at each end. The scaffold weighs 200 newtons and is 3 meters long. What is the force in each rope when the window washer stands 1 meter from one end? So first thing I'm going to do here, I'm going to draw a picture of what we're looking at. So we have our scaffold. With two ropes holding it up on each end. And we have a person standing 1 meter from one end of the scaffolding, the window washer. Alright, so next, first step. What I know and need to know. Okay, well, we've been talking about torque. Torque is equal to force times distance. So that should clue you in on some of the information that we need to know. Let's see things that we're given. So we're given that our window washer has a force of 700 newtons. So the force of the washer is 700 newtons. We are told that the distance of the washer is 1 meter from the end, but I'm not going to write that yet. Okay, next we're also told the force of the scaffolding is 200 newtons. Well, where would that be? That'll act from the center of mass. So center of mass, that force on the scaffolding is 200 newtons. And that distance, again, it'll be in the middle of our 3 meter long scaffolding, but I'm not going to write it down quite yet. Okay, then we have two tensions, tension 1 and tension 2, and I don't know either of those. That is what I'm trying to solve for. Those are our forces we're trying to solve for, T1 and T2. And they will also have some distance that I'm going to solve for. So there's step 1. I wrote down what I know and what I don't know. Step 2. Step 2, I'm going to pick a pivot point. Change my layer here. Okay, step 2, pick pivot point. Okay, and I'm going to choose a pivot point at one of the locations of the information I don't know. So I'm going to choose this one right here. I don't know the tension on T2, so I'm going to set my pivot point there. Could also do it at T1. It won't make a difference, but I'm going to set it there. So now that I have a pivot point, I can also find distance. Okay, so from that pivot point, I can find the distance from the pivot point to my washer. All right, he's 1 meter from this end. 1 meter from the end of a 3 meter board means he's 2 meters from my pivot point. So this distance of the washer is going to be 2 meters. My center of mass of my 3 meter board from one end is 1.5 meters. The distance for T2, or sorry, from T1 to T2, a little bit farther, is the 3 meters that make up the board, and the distance from my pivot point to T2 is 0. Okay, so now step 3. For step 3, I'm going to draw arrows of rotation. Okay, so if my object is locked at this point, I want to draw the direction my scaffolding would rotate based on these forces. So if this was the only force, my scaffolding would rotate that way. If my washer was the only force, my scaffolding would rotate that way. And if the tension was my only force, the scaffolding would try to rotate that way. Now the reason I want to do this is because for our last step, I want to remember that the tension in the clockwise direction has to equal the tension in the counterclockwise direction. Why? Because the scaffolding's not moving. It's not actually rotating. So that means the tensions in each direction have to be equal. So I look at that, my tension clockwise, the direction the clock is going, is going to equal the tension of T1. And my tension counterclockwise is going to equal these two. My tension of my washer and the tension of the scaffolding. Okay, so then I go back to this equation we talked about earlier. Tension is force times distance. So the tension of T1 is going to equal the force. The force is T1 times the distance, and the distance for T1 is 3 meters. And over here, the tension of the washer is 700 newtons times a distance of 2 meters plus 200 newtons times a distance of 1.5 meters. Okay, so if I set those two equal to each other, T1 times 3 is going to equal 1400 plus 300, so equals to 1700. That means T1 is equal to 1700 divided by 3, which gives me 567 newtons. So there, I've solved for the tension on 1. So that's 567 newtons. Now, we still need to solve for 2. And there's 2 ways we can do that. The first one I'm going to show you is by doing all of this over again, but picking a different pivot point. And the second way is related to material we covered earlier in the school year, and I'll show you both. So let's turn, there we go. Alright, so the things I know are still the same. The drawing is still the same. But for step 2, I'm going to pick a pivot point. And I'm going to choose the opposite side this time. I'm going to choose T1. Okay, so now I can set my distances. So the distance from T1 to my washer is now 1 meter. From T1 to my center of mass is still 1.5 meters. And from T1 to T2 now is our 3 meters, and this one is 0. So step 3, rotation. So if I'm pivoting here, this is going to act in that direction, this one will act in this direction, and T2 would be pulling it up in that direction. So again, my torque clockwise has to equal my torque counterclockwise. Torque clockwise, the direction the clock is going, is the tension of the washer plus the tension of the scaffolding. And the torque counterclockwise is now just the torque of T2. So I'll plug my numbers in just like I did before. The torque of the washer is 700 newtons times 1 meter, plus the torque of the scaffolding, 200 newtons times 1.5 meters. And the torque of T2 is unknown. It's the tension 2 times its distance 3. So I plug those numbers in. So T2 times 3 is going to equal 700 plus 300, so equals 1,000. And therefore T2 equals, it's 1,000, equals 333 newtons. So T2 is 333 newtons. Now, as I mentioned, in previous chapters, go ahead and erase a few things here. In previous chapters, we talked about balanced forces, right? So balanced forces, if the forces up equal the forces down, my object's not moving, right? Well, my scaffolding isn't moving, which means, pick a good color here, let's go with, we haven't used purple, there we go. So my forces up have to equal my forces down. So if I look here, I know this force down and this force down, and remember, we're rewinding here, I knew T1 was 567 newtons, but I didn't know what T2 was. Okay, I'd solved for T1 earlier, I didn't know T2 yet, and that's why we went through the whole process again. Well, forces up, what do I have up? I have T1 plus T2 equaling my forces down. The force of the washer plus the force on the scaffolding. So 567 newtons plus T2 is going to equal 700 newtons from my window washer and the 200 newtons from my scaffolding. So T2 is going to equal 900 minus 567, which equals our 333 newtons. Okay, same answer we got by doing the whole torque rotational equilibrium steps. So hopefully that helps with number 19 and with some of the other homework problems in this section. If you have any questions, please let me know. We're going to try to post the test on Thursday, and you guys will have Thursday and through the weekend to find some time to study, prepare, and work on that test. If you need help, let me know, and I'll keep creating more videos to try to help you.